So my presentation is on iron. Iron is an essential trace nutrient. It's essential because our bodies cannot create it on its own. So we need to eat it to get it into our bodies, and it's a trace mineral because our bodies don't need very much of it in comparison to other nutrients, but it's still really important. So the tolerable upper intake level for iron is going to be 45 milligrams a day. And the RDA levels for infants 0 to 6 months is going to be 0.27 milligrams a day. And for 6 to about a year, it's going to be 11 milligrams a day. Infants are usually going to meet their iron RDA levels through their mother's breast milk or fortified iron formulas. Babies with poor iron stores might need iron supplements, but this is only at risk for a baby if the baby is born prematurely or born underweight. 6 to 12 months infants have a higher iron need because of cognitive development. And then for children, 1 to 3 years, 7 milligrams a day is going to be the RDA, and then 4 to 8 years, it's 10 milligrams a day. For males, it's going to be 8 milligrams a day pretty much throughout life except for 14 to 18 years. RDA for women, 9 to 13 is going to be 8 milligrams, and then 51 to over 70 is going to be about 8 milligrams a day. 13 to 50 is going to be either 15 or 18 milligrams a day because of menstruation, because of loss of blood, and then pregnant women should consume about 27 milligrams a day. So the functions of iron in the body is there isn't a lot of free iron in the body because it's dangerous. Free iron can form free radical compounds that will destroy cell membranes and DNA. This being the case, there's very little free iron in our bodies. Most iron is bound to a transport, functional, or storage protein. But iron is an essential part of hemoglobin and myoglobin, and those proteins are both involved with the transport and metabolism of oxygen. And here's a chart just from our textbook that lists the different functional proteins, transport proteins, and storage proteins that contain iron in them. So hemoglobin, iron gives hemoglobin the ability to carry oxygen, and hemoglobin is a component of the red blood cells, and it contains 4 iron heme compounds, which each bind to one oxygen molecule. And so the iron then carries oxygen through the blood from the lungs to the body tissues, and that's how oxygen is transported. Myoglobin is very similar to hemoglobin as it aids in oxygen transport, but the difference is myoglobin contains one iron molecule and it delivers oxygen from the heart to the skeletal and heart muscles, or sorry, from the lungs. So other functions of iron. Iron is a cofactor for the enzyme involved in the synthesis of neurotransmitters, which are key in cognitive development and brain function. And we see that in the infancy stage of life, how children have a higher RDA of iron. That's for cognitive development. And iron containing enzymes are also key energy metabolism. So in the mitochondria, iron containing cytochromes carry electrons to the electron transport chain. So dietary sources of iron. There are two types of iron. There's heme iron, which is mostly found in animal tissues, and it is comprised of hemoglobin and myoglobin because it's in animals. And so the sources of that iron, of heme iron, are going to be beef, pork, seafood, and poultry. And heme iron is readily absorbed by our bodies. And then there's also non-heme iron, which is found in plants and in iron elements of animals. And that's going to be vegetables, grains, and supplements. And non-heme is less efficiently absorbed in our bodies. So iron deficiency in the body. If you have a mild iron deficiency, mild to moderate, the effects are going to be it's going to compromise the immune function and you're going to have a poor work performance. In severe iron deficiency, it's called anemia. And symptoms include impaired oxygen transport to the blood, compromised immune system, impaired energy metabolism, delays in cognitive development, and fatigue. And this is going to be because all those proteins that we have talked about that need iron to function, like hemoglobin and myoglobin and the other energy metabolizing components of iron, are going to be impaired because you have a deficiency. And so, like we discussed, the results are going to be, impaired oxygen transport, and then delays in cognitive development, and then tiredness. So those who are at risk for iron deficiency are infants who are born with low iron stores, children who consume little iron-rich meats, menstruating women and teen girls and pregnant women, and people who donate blood more than 2 to 4 times a year. Next, we have iron toxicity. So the UL is 45 milligrams a day, and intakes higher than this can cause nausea, vomiting, stomach irritation, diarrhea, and impair absorption of other trace minerals. So iron toxicity levels in children is usually going to be accidental iron overdose, and it's the leading cause of poisoning in children 6 years and younger. Children's absorption mechanisms do not respond as rapidly as adults, and so the iron is just going to be absorbed. And this is mostly caused by an intake of chewable, excess intake of chewable iron-containing supplements. So, leaving your chewable vitamins out that have iron in them, and children getting a hold of those and eating those, and overdosing on iron levels that way. And in adults, iron toxicity is called hemochromatosis, and it is a genetic disorder that disables the mucus block that usually protects the body from an overload of iron absorption. And so this causes iron deposits in the liver and the heart and other organs. Interesting fact, one way you can increase your iron intake without changing your diet is to cook in cast iron pots and pans. So the iron in the pots and pans is going to absorb into the food and increase its iron content. This works best with moist, acidic foods that will pick up most iron. And so the examples that I gave was like applesauce or chili, foods kind of like that. And it doesn't really work with dry, non-acidic foods, so pancakes or kind of foods like that. And the result is going to be about 6 to 8 milligrams of iron absorbed per 1 cup of food prepared in an iron cookware. So iron in the media, I found an interesting article about women who choose to encapsulate their placenta after delivery and consume it as an attempt to restore nutrients to the body. And I'd heard about this before, and so I was reading on it. And some women do this to prevent fatigue and anemia, which are both symptoms of iron deficiency, which can happen during postpartum. And the study shows that this is not an effective practice, and encapsulated placenta offers no iron nutrient to women during postpartum. So in this study, they had a group of women who took their placenta, and then another encapsulated placenta, and then another group of women who took a placebo, and they had across the board the same iron levels. So there was no increase, and so if you have anemia, then the best thing to do is to just take iron supplements. In conclusion, iron is an essential is essential for oxygen transport and energy metabolism and cognitive development. For us, if you're eating well, if you're eating a well and balanced diet and you're living the word of wisdom, your iron needs are usually going to be met. The only case where it wouldn't be is if you have a higher RDA because of pregnancy or menstruation, then a supplement is recommended to increase those, increase the level of iron that we are eating. And yeah, here are my sources, and that's it.